So how do you use a pre-trained embedding matrix? Well, let's look at the problem that we were talking about, the Twitter postings, and wanting to know whether they're positive or negative. So what we could do is we could construct a fairly simple neural network. We already talked about the fact that we will have a bunch of words coming in. So up to 75 words. Let's just call them word 1 through word 75. And then what we would do is make sure these words use the, let's just use glove, say the glove dictionary. Okay? So we go through and we say there's a word, let's say in Twitter, that is jump. We find out where it is in the glove dictionary. We find it's 1,234, and we make that number here be a one-hot encoding of 1,234. And they do the same thing for all the other words. We will talk in a moment about what happens if there are words that aren't in the dictionary. And then we'll go ahead and use this embedding matrix and feed all these words into the embedding matrix and feed that then into our neural network. And out of this, we'll get our YHat. So because we're using this embedding matrix, it's going to be extremely easy for this neural network to be able to understand that happy and elated and perhaps excited and some other words like that are closely related to one another. And so it would be easy for it to learn that they all, if it's an example for one, that it leads to a positive review, that all might lead to these positive reviews, because all these are close in this n-dimensional space. What do we do if we have a word that's not in here? Well, what we could do is we could just go ahead and extend. So let's say we've got E, and it had 10K inputs. Okay, and this is maybe 50 wide. And let's say we've got a bunch of words that are not found in this dictionary. Okay? So, let's say we're using Twitter, and we have GameStop or something. So hashtag game. That is popular. So we can go ahead and add, let's say, some more entries to this embedding matrix. Now they're not pre-trained, right? We didn't get them pre-trained from Glover Word2Vec, so we'll add 100 more, okay, which are the common ones that we find in our corpus. And then we can randomly initialize. We randomly initialize these weights, we put it in here, and then what we do? Well, what we probably do would be train. And of course, something like this word that wasn't part of the embedding matrix, what part of that dictionary, we would go ahead and map into one of these values. We go ahead and let's say train the neural network, keeping the embedding matrix frozen, because we don't want, as we initially start training this neural network, for these carefully pre-trained weights to get screwed up by the fact that we have lots of gradient because we're making high losses because our neural network is random. Well, as this eventually gets better, as our loss gets low, then, just like we normally do when we're doing fine-tuning, we might start unfreezing these weights. And now all of a sudden, these random initializations we'll start learning from that and setting values for here, adjusting these weights. So probably these will have fairly large adjustments, and these will have fairly small adjustments because we don't have much gradient loss associated with these, but we'll have a lot associated with those. So that's roughly how you might use embeddings. You would download an embedding, and then rather than directly after your one-hot encoding of a word, you go ahead and run it through an embedding matrix.